Hello everyone, welcome to Engineering Archives. In this video we are going to look at learning problem number 6 for the chapter dot product. So this question says, determine the component of projections of the force along the line OA. Alright, so the question is pretty simple. It wants us to find the projection, the component of projection of the force, which is 650 newtons, along this axis or along this line OA. But notice in the question that they do not mention the word magnitude, right? And whenever they don't mention the word magnitude, it means they want us to find a vector component. So the component of the vector and not just the magnitude of the vector. In one of the previous problems that we did, the question did not mention the word magnitude, but they did want us to find the magnitude. And this is a glitch that the book has. Sometimes they don't mention the word magnitude, but in fact they do want us to find the magnitude. And but you have to be careful for those problems. But whenever you get any question like this in your examination, you should always ask your instructor to clearly state if the question wants you to find the vector or the magnitude. For me, whenever the question says magnitude, I go for the magnitude. Whenever it does not mention magnitude, I just go for the vector. And that is exactly what we are going to do in this question. We are going to find the vector form for the component of the 650 Newton force along the OA line. So we know that the third formula deals with projections on an other line, right? And in this question we can find the angle theta easily. So let's first write down the third formula. So the third formula said the vector component of a force along an axis B is equal to magnitude of the force multiplied by cos of the angle between the axis and the force multiplied by unit vector in direction of the axis, right? So let's write that down. Vector component of the force, so vector component of the force along the line OA is equal to magnitude of the force multiplied by cos of the angle theta between the force and the axis OA multiplied by unit vector of OA. Alright, so there is no dot product in this formula. All of these quantities are just being multiplied by each other. Now that we have our formula, we can move on to find the quantities that we require. The question gives us the magnitude of the force, which is 650 newtons. We need to find theta. So from this diagram, we can see that they have given us this small right angle triangle right here. So let me draw a bigger version for you. And we need to find this angle theta. In order to find this angle theta, we will first find this angle. Let's call this angle phi. Okay, so tan of phi is equal to 12 by, I accidentally switched the two values. Yeah, so tan of phi is equal to 5 over 12, which means phi is equal to, take the arccos of both sides and you get 22.62 degrees. Since phi is 22.62 degrees, theta would be 90 minus 22.62 degrees, and so we get theta is equal to 67.38. So 67.38. Alright. So this angle is 67.38. Okay, now that we have theta, we can move on to find the unit vector in direction of the OA axis. So let's first draw an imaginary unit vector along the OA axis. let's say this is our unit vector, okay? And we all know that the unit vector has a magnitude of 1. So the length of the unit vector, or its magnitude, is always equal to 1, right? And we know that this angle right here is 22.62. So we can use this angle to find the components for this unit vector along the x and the y axis. So the x component for this unit vector is going to be 1 cos of 22.62i, while the y component for this unit vector is going to be 1 sine of 22.62j. And let's just replace these identities with fractions, right? So cos of 22.62 is equal to 12 by 13i, while sin 22.62 is equal to 5 over 13j. Okay, now let's put all of this stuff into this formula to get vector component. So 6 newtons multiplied by cos of theta is 67.338, and finally our unit vector is 12 over 13i plus 5 over 13j. Once you multiply all of this, you will end up with 229i plus 96.2j. So this was a simple procedure for this question. You will notice that in this question we used the third formula. Okay, so this is the only question in which we use the third formula, I think. Yeah. So practice with these formulas, they are not difficult. See you in the practice problem video.